Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and today we're going to take a look at variables, naming conventions and PEP 8 guidelines. All of this is for the Python Certified Enterprise Level Programmer, and we're getting through to the last of the objectives for our topic 1. Now, beginning by taking a look at variables, we've already seen our variables as we've been writing code. These are containers that are used to store data for future use. They become a named object inside of Python. Now, we're likely to use it. Let's say if we need to access a file, we can reference the file through a variable name. We can configure the variable name once, often very early on within our script, and then make reference to the variable as we execute the script. So we set the name once, but we can access it many times. If we ever need to change the file, we only need to change the file name in the one place where the variable is set. The next important thing to understand is that variables reference the memory location of the stored value or values. Now, why is that important? Well, some variables reference objects that are immutable, such as strings and integers. So if we change their values, we're creating a brand new reference. Whereas other objects that we can reference, such as lists, are mutable objects. This way, if we change a list, we're not changing the reference. Now again, I can see you're still probably not very clear on that. So if we go through and have a variable a assigned the value of 4, 4 is an integer which is immutable, it cannot be changed. We can set another variable b to be assigned the value of a. So both b and a are equal to 4 at the moment. They reference the same object. But if I change the value of b, b now is assigned the value of itself plus 1. The original object is immutable, so we create a new reference. When we take a look at a, it still has a value of 4, whereas b now has a value of 5. We created a new reference when we changed the value of b. Now compare that to lists. Here we're creating a list that we store in the variable a. Lists are mutable. They can be changed. We can assign b to be equal to a. So both b and a now are a list with values 1, 2, and 3, and they're pointing to the same list. If we then append the value of 4 through to our list b, this is changing both a and b because we can change the original object. Lists are mutable, strings and integers are immutable. So when we go through and print out a, we can see that it's got a value of 1, 2, 3, and the newly added value of 4. When we look at the naming rules, variables are case sensitive. So my underscore var with an uppercase m is not the same as my underscore var in lowercase. These are different variables. Variable names must start with a letter or an underscore. So underscore my underscore var1 is okay. My underscore var1 is okay. But when we try and start it as one my underscore var, that's not okay. Variables must begin with either an underscore or a letter. They can only contain letters, numbers, or the underscore. So user underscore name is a great name. User hyphen name is not a name that you can use. User at name is also not allowed. We can only use letters, numbers, or the underscore. When we look at user1 underscore name, there's no problem in this. It starts with a letter. It only contains numbers and underscores, so we are good to go. We also cannot use keywords. So things like class or def or for or while, all of these are keywords, and keywords should be avoided. When we look at our PEP 8 guidelines, our Python enhancement proposals, these are recommendations. They are not enforced. So they'd like us to use snake case, where we have to use multiple words. So my underscore var or user underscore name. It helps readability and helps create descriptive names. Error underscore file, all of these are good. So we want descriptive names. My underscore var1 is not really descriptive, so we shouldn't use it. Whereas we use something like width or length. Now I know we're not using snake case here, but we might not want to use things like room width or room length, because we might be providing just a width and a length, and that might be for a room, or it might be for a box, or it might be for anything. So we don't need the extra words, but they are still very descriptive. Also, when we're looking at Boolean values, using is underscore staff, we can see then very simply that this should be containing a Boolean value. The constants. There is no real thing as constants inside of Python. We have variables, and variables mean that they can be changed. Whereas we can try to use constants, and if we are going to use constants, we should use uppercase to indicate the intent of that variable. It is still a variable, but by using uppercase, we're really saying that we want to use this as a constant. A constant doesn't change during the script execution. So once set, the constant's value is maintained. Now, whilst Python doesn't enforce this, we can indicate the intention of that variable. And the last thing to mention here is scientific notation. When we're using scientific notation, we should use a lowercase e. We could use an uppercase or a lowercase e, but as far as the guidelines, let's stick with a lowercase e. So when we're writing a large underscore number, we can put 1.23 e and then to the power of 10. So let's get into our demonstrations. It's these demonstrations where you're really going to get the power of practice and memory. So let's go through and take a look at what we mean by variables and their references. Look at some naming rules along with those PEP 8 guidelines. For our last topic of this objective, we're going to be taking a look at variables, naming standards, and PEP 8 guidelines. Come on, let's get into it. So we're going to take a look now at using our variables. And it does seem that we've been using variables throughout the whole of this training. But that was just as we were going along, just getting used to seeing some of these items being used. We're now going to concentrate on looking specifically at variables. The first thing we're going to look at is really what a variable is. And a variable is a reference to an object in memory. So if I had a variable called a and assign it the value of 4, 4 is an integer. Integers are immutable. They cannot be changed. When I look at executing the code, we can go through and check that a has a value of 4. But let's now go through and assign b to be the value of a. When we look at this, both b and a now are pointing to the same location. So they both have a value of 4. So everything seems to be right. A is pointing to the location of the integer 4 in memory. B is pointing to that same location. But if I now go through and say B plus equals 1, and then shift and enter, we can't change an integer. They are said to be immutable. So we've created a new reference now for B. So A and B now are pointing to different locations. So when I look at the value of A, it is the original 4. Looking at the value of B, it is the newly assigned value of 4 plus 1. So because the integer couldn't be changed, we had to create a new reference. Whereas if we looked at something like this, where we point to a list, we can have A now pointing through to a list. That list can have our values. So we put lists inside of square brackets. The list can contain anything. We'll have a list of integers, 1, 3, and 9. We can close off our list, execute our code, and of course, when we look at the value of A, we can see then that it is a list with values 1, 3, and 9. When we look at the type of A, and let's go through and execute this, we can see that that is a list. Lists are mutable. So again, if we have B being assigned the value of A and B now both point to the same list. But because the list is mutable, if we change B or if we change A, but let's have B dot append, and let's go through and append a value of 99 to it. Let's go through and execute our code. Now when we look at A, we can see that it's got a value of 139 and 99. And of course, when we look at B, it also has that same value. So it all depends the type of object that we are pointing to. If we're pointing to an immutable object, such as an integer, a float, or a string, then they cannot be changed. So changing the value of a variable will create a new reference. Whereas something like a list is mutable, so changing the value of my variable B doesn't need to create a new reference. So A and B are still pointing to the same list, but they now have the extra item appended to it. Again, practice, practice, and practice, and you will become more familiar with this, and it will start to settle. When we look at naming our variables, obviously single character names like A and B are not descriptive, so we don't really know what's going on. So we would prefer something like user, and if we need to go into two names, use an underscore, so we're using snake case, equals, and then Andrew. This way we know quite clearly what is stored within that variable. Variables must begin with either a letter or an underscore. Underscore often would be used to indicate a more private variable, although it's not enforced. The only characters that can be contained within a variable are letters, numbers, and underscore. So a variable cannot start with a number. So I could try and have one var equals 2. And when we look at this and then shift and enter, we're getting a syntax error. Whereas I can have var1 equals 2. But var1 doesn't describe anything to me. So as far as the guidelines are concerned, we would have things like width equals 2. So we can understand what that variable does in our code. That might be when we're looking at it today, but most likely when we're looking at it in 6 months' time, when we're coming to review the code. So let's be kind to our future selves. We can start a variable with an underscore, so we could call it underscore width equals 2, and this is perfectly okay. Variables are also case sensitive, so if I go through and put width with a uppercase W, and we can have a value of 3 here, these are completely different variables. So when we look at underscore width, and let's run that code, that's 2. Whereas we look at it with the uppercase W and execute that code, it's got a value of 3. So variable names, no matter the platform that you are using, are case sensitive. Generally, we're going to use lowercase names. If we use an uppercase name, we might go through and put, say, log underscore file equals, and we can have it, I don't know, log dot text. There's nothing wrong with that at all, but that indicates that the variable log file has the intention of being a constant. Python doesn't enforce constants. Constants can be set, but then cannot be changed, whereas variables can be changed. So Python does not have the concept of constants. However, developers do. So we can indicate our intention that log file once set is not to be changed by setting a fully uppercase name. So hopefully this is giving you a good idea of variables, setting up your own variables. But again, practice, practice, and practice, and make sure you're aware of what you can do and what you can't do with variables.